Manchester encoding. I explained you in RZ level scheme, a return to zero level scheme, there is a problem of self-clocking, and it's also wasting 2 voltage transitions per bit, correct? 2 voltage transitions per bit, and it has DC component problem. I explained to you what is DC component, the average of the voltage values, correct? That is the reason they came up with a scheme called as Manchester encoding, okay, which eliminates all these problems. Not all, it still has the problem of 2 voltage transition per bit, but the thing is, it is eliminating DC component and self-clocking. If you don't have 2 transitions per bit, you cannot synchronize your receiver at any cost. Getting? Now, the idea of the Manchester encoding was the bit 1 is represented by a voltage transition from low to high as per IEEE. Remember this. Voltage transition from low to high at the middle of the time period of the bit. At the middle of time period of bit. Okay, transition occurs at the middle of the time period, okay, and 0 is represented by high to low. Okay, now let me tell you, in some textbooks there is high to low, in some textbooks there is low to high. I am telling you on the basis of IEEE scheme. On the basis of IEEE scheme, Manchester encoding. In Manchester encoding, bit 1 is represented by low to high transition of the voltage level, okay, and 0 is represented by high to low. But the person who discovered this Manchester encoding says that 1 is represented by high to low, 0 is represented by low to high. Now the question is, which you must answer in interview. In interview, you must answer the one which is followed by IEEE scheme, okay. Now let's take the example 01001. Okay, we have the graph here. There are 5 bits: 1 bit period, 2nd bit period, 3rd bit period, 4th bit period, 5th bit period. Okay, time period 1, I mean time period of bit 1, time period of bit 2, time period of bit 3, time period of bit 4, time period of bit 5. This is positive voltage, this is negative voltage, this is 0 voltage. Okay, now taking the example of this bit, how is 0 represented? Okay, do you know how clock flows, right? Like this. I don't want to draw the clock right now. Okay, it's simple, bro. If there are 3 bits like this, the clock just goes on like this. Okay, getting clear? It just clock signal is like this. Okay, clock signal flows like this. Okay, now let's see how 0 is represented. Firstly, the voltage is at 0. Now this fellow wants to represent 0. I told you 0 is high to low. The signal shift here to the high positive voltage comes here. I told you there is always a transition of the bit at any cost at the middle of the time period of the bit. So this is half the time transition occurs from high to low. Clear here? Now comes here. Okay, the next bit is 1. I told you 1 is represented by low to high, so it continues here. Now low to high transition occurs here. Clear? Okay, now it flows till here. Now the next bit is 0. I told you 0 is represented by high to low. It comes here, half of the time period, transition, take transition and continue. Next bit is again 0. If again 0, again it must go till high and come to low again. It will shift here, and it will come here, middle of the half bit period, it came back to negative voltage. Okay, now it continues like this. Again it is 1. 1 means low to high as per IEEE. Go here, half of the time period bit, shift, continue. So this is a graph of Manchester encoding. First it goes like this, again it comes back like this, again it goes like this, again it comes back, again it comes back here, it goes like this, again it goes like this, continue. Okay, by this arrow marks you can understand how the voltage is actually fluctuating at the middle of the time bit period of the bit. Fine, this is nothing but Manchester encoding. Now coming to what are advantages of Manchester. Self-locking, DC component eliminated. Okay, these two are advantages. Okay, coming to what are disadvantages. As you can see, there are many voltage transitions. If there are many voltage transitions, it has higher requirement of bandwidth. Am I right? Higher bandwidth requirement, correct? 2 voltage transitions per bit. That's it. That's about Manchester. Understood? Now, differential Manchester. Differential Manchester encoding. To overcome the polarity issue caused by Manchester encoding, this BAP scheme came. Okay. In this Manchester, mid-bit transition occurs at any cost. It should occur. At any cost, it should occur. Middle bit transition is occurring, but one at the start of the bit period, it will be at the positive voltage side. It will be at the positive voltage side. 0 at the start of the bit period will shift to negative voltage, negative voltage side. Okay. I mean that case, right? It was a transition which was deciding in the mid bit period. Here, transition is occurring at the signal start only. The signal start only. Okay. I will explain the graph and explain you. I'll draw the graph and explain you. You'll understand. 0 1 0 0 1. Same example. Okay. Same example. Hey man. Okay. Their mid-bit transition was occurring because of the change in bit. Okay. Here mid-bit transition will occur at any cost. 1, 2, 3, 4, 5. Okay. We have 0 here, we have 1 here, we have 0 again, 1 again. Okay. The graph is here, and here we have positive, here we have negative. The signal starts here. This is the signal. It says first is 0. 0 is represented by negative voltage. 1 is represented by positive voltage. 0 is represented by negative voltage. At the start, not the entire bit period. At the start, okay. Starting point. It will not remain constant for every whole bit period, whole time period of the bit. Okay. Now it will come here 0 as it is represented by 0, as it is represented by negative voltage. It will come here. It will come till half bit period. Negative. Decided it's negative. At the middle bit, the transition will occur at any cost. It should go back wherever. If it is negative, it will go to positive. If it is positive, it will come back to negative. There, it was decided on the basis of bit. Okay. Here it's not like that. It will come here. We see the next value is 1. 1 means remain at the positive voltage. It will remain here. Understanding? Now it will remain here. It will come back again to opposite side. It will come back here. Now if it says again 0. 0 means remain at the negative. It will remain at the negative. But at mid it will take a transition. Mid at any cost it will take a transition to maintain synchronization. Okay. Come here. Again it is 0. 0 means be at the lower. Take a transition again. Now it will come back here. It will say 1. 1 means remain at positive, but at middle take a transition. That is differential Manchester. Now you think general knowledge, even if polarities got changed, here the signal will remain same.